Alrighty. Assalamu alaikum kids. So inshallah in this video we'll discuss the May-June 2021 P4, Physics P4. Okay, so let's move on towards the very first question. Our very first question says, student investigates how the potential difference across a fixed resistor R changes as extra resistance is added to the circuit. She sets up the circuit shown in figure 1.1. Cool. So we have sort of a potentiometer set up. She connects the crocodile clip C to a point on the resistance wire at length 20 from end X. She closes the switch. She reads the voltmeter, records the reading. She opens the switch. All right, so take a figure 1.2 shows the voltmeter reading. Read the voltmeter scale in and in table 1.1 on page 4 record the potential difference V. So page 4 लेंथ 20 के ऊपर हमें potential difference जो है वो लिखना है. So we can easily say that, all right, so you've got this right here should be a 1.5 because आपके पास total जो है वो 10 divisions हैं. तो each division is going to be how much? It's going to be 1 divided by sin, hence 0.1 volts. So according to that, that's going to be 1.1, 1.2, 1.3 and 1.4 volts. ठीक है, तो इस तरह से सुकून से you can easily tell that, all right, the total reading is going to be 1.4 volts. ठीक है, I hope that makes it clear. Calculate 1 upon V and record its value 1.1 on page 4 to appropriate number of significant figures. ठीक है, 1 upon V कैलकुलेट करना है तो 1 upon 4, 1 divided by 1 upon 4 हो जाएगा. 1.4, sorry. So this right here is going to be 1.4 and 1.4 divided by, so 1 divided by 1.4. I don't have a calculator with me, but I'm thinking that this right here is similar to the value of root of 2, and root of 2, 1 upon root 2 is approximately 0.7. I'm gonna go ahead and say that this right here is going to be 0.707 hota hai, so I'm gonna say that this right here is going to be 0.71. Take it approximately, of course, maybe a little more than that, maybe just slightly a little more than that. Take it. All right, so this right here is for the length 20. So we did part 1 and part 2 for A. Let's start with B. B says she repeats the procedure using values length 30 centimeters, 40, 60, 80. Suggest why the student opens the switch between readings. तो opens the switch between the readings, तो आप जो है बहुत सारे इसके आंसर्स दे सकते हैं. जाहिर सी बात है, if you look at it over here, so we have a battery, all right? And because there is a battery, we can say that, okay, the battery drains, the battery gets hot, because of which your EMF would change. आप जो है वो ये कह सकते हैं कि because the wires will get hot, तो जाहिर सी बात है उनका resistance change हो जाएगा. So the point of switching off the circuit or opening the circuit would be to let everything cool down, return the resistances and everything to their normal points. So आप यहाँ पे लिख देंगे, suggest why the student opens the switch between readings to allow the circuit to cool down as the resistor wires or the cell can get heated. सही. जाहिर सी बात है, we just need to suggest why. Of course, अगर question यहाँ पे explain बोलेगा, तो you can say that electrical energy is converted to heat energy, which will then increase the resistance. And अगर हम इसको cool down नहीं होने देंगे, तो आपकी values जो हैं वो affect होंगी इससे. Part C says, on the second grid provided, figure 1.3 on page 5, plot a graph of 1 upon V on the y-axis and L on the x-axis. Start both axes from the origin, draw the best fit straight line. Cool. So we definitely can do that. What we need to do that on page 5. Okay. All right. So we have this graph paper right here. So we have to start at the origin. So अच्छा अब ग्राफ यूज़ करते हुए you need to make sure that you're using at least half the graph. ठीक है, I hope कि ये बात जो है वो सबको याद है. Again, we've went over that quite a few times now. So on on the potential difference side, the question says अच्छा potential difference तो plotting नहीं करना, हमें 1 upon v plot करना है. All right, that's cool. So 1 upon v goes on the y-axis while the length goes on the x-axis. So for the length, we need to plot between 0 and 80. For the potential difference, we need to plot between 0.7 and 1.3. All right, that's cool. So we can say, अच्छा question क्या बोल रहा है कि we need to start both axes from the origin. Okay, we can do that. So if both axes start from the origin, the y-axis के ऊपर मुझे 1.3 तक जाना है. Now how many points do I have? So I have this right here. Let's say 1, 2, ठीक है, and then 3, then 4, and then 5, 6, and 7. So the only way I can fit 1.3 in that is if I consider the first one to be 0.2, 0.4, ठीक है जी, 0.6, 0.8, 1.0. अच्छा जी 1.0, then we've got 1.2 and फिर 1.3 यहाँ पर होगा, तो जाहिर सी बात है 1.4 goes like so. And x-axis के ऊपर we had to go till 80. So 1, 2, so 1, 2, 3, 4, 5, 6, 7, and 8. So we can go to 80 approximately. Oops, sorry. So 20 over here, 30, 40, 50, 60, 70, and 80. Alright, so essentially we've put down, अब जाहिर सी बात है यहाँ पे labels लगाना ज़रूरी है, right? So you've got to label your graph. This right here is 1 upon v, ठीक है? And this right here is length. This right here is the length. Alright, of course the length is in centimeters if I'm not wrong. इसको एक बार ऊपर जाके वापस देख लेते हैं. So your length is in centimeters, yes. Your potential difference 1 upon V is going to be in the units. अब आप 1 upon volts लिखें या volts minus 1 लिखें, वो आपकी मर्जी है, सही है. But again, number 1, एक scale proper आपने देना है, ठीक है. Scale का probably एक mark होगा. So the way we have written down the values. Then labeled axes, that's going to be one correct, 1 point as well. ठीक है, then we need to plot the points. So let's start plotting the points. So what we can do is we can say कि 1.4 sorry 20 पे 0.71 है, 30 पे 0.77 है, 40 पे 0.91 है, 60 पे 1.1 and 80 पे 1.3. Alright, so let's start plotting these. 7, 1, 7, 7, 9, 1, 1.1 and 1.3. So 20 pe it's 0. So this right here would be 0.71. Sorry, 0.7. My bad. The 0.71 would be somewhere in the middle. क्योंकि ऊपर 0.72, then 0.74, then 0.76. Again, these 5 divisions would be 0.2 each. So if this right here is 0.7, the 0.71 जो है वो यहाँ पर होगा. Of course, what you need to do is you need to circle your points. Once you plot a point, उसको circle ज़रूर करें. 30 पे 0.77 था, so 0.77 should be over here. ठीक है, 30 पे 0.77 हो गया. 40 पे if I'm not wrong it was 0.91. 0.91 40 पे, yep, 0.91, 1.1 and 1.3. So 0.9 would be somewhere over here. 0.91 हो गया. 50 पे 40, that was on 40. फिर you've got 60. 60 पे we've got 1.1, 80 पे we've got 1.3. 60 पे we've got 1.1. So 1.1 would be somewhere over here. Exactly. And 80 पे we've got 1.3. So 1.3 should be right here. Okay, so I'm thinking that we draw a line of best fit that essentially would pass through as many points, and then we are going to have an equal number of points above and below. अब जाहिर सी बात है आपके पास एक scale होगा with which you can tweak how you're going to draw the line. So let's try and do that. So I'm guessing that ताकि मेरा y-axis भी fix हो जाए. Okay, so I'm thinking that this line right here should do just fine. उसका reason ये है कि you've got this point right here, which is below the x-axis, below the line. You've got this point right here, which is above the line, and then you've got 1, 2, and 3, which are on the line. So yeah, I'm thinking that this right here is a line of best fit that I can use. Cool है, ठीक है. तो ये काम तो हो गया. Then the question says, so ये 4 marks हो गए basically. So एक mark correct scale, दूसरा mark labels, तीसरा mark correctly drawn points. अब आप अपने points जो हैं वो अपनी मर्जी से आगे पीछे नहीं कीजिएगा कि भाई line of best fit नहीं बन रही, points आगे पीछे कर दिए. No, because they will check कि आपने exactly correct points जो है वो plot किए नहीं किए. So don't do that, all right? And then we can start from the next point. अच्छा, line of best fit बनाने का 1 mark हो जाएगा और correct points plot करने का जो है वो 1 mark. So that's how you're going to get these 4 marks. ठीक है? I hope that makes that clear. Calculate the gradient m of your line. Show all the working indicate on the graph the values you use. How are you going to indicate on graph the values you use? So I'm going to first try and pick points that are nearly exact points, at least half of the graph away from each other. All right. So I can think of this point right here. ठीक है, एक ये point ले लेते हैं या तो फिर इससे थोड़ा दूर चले जाते हैं. Let's take this point right here. So yeah, so I'm taking this point right here, and let's take this point right here. All right. So मैं ये दो points ले रहा हूँ. Of course, how are you going to show them? You're going to draw a triangle. ये तो exact line पर है, so that must be an easy job. All right, but again, I'll just use. आप लोग again, you're gonna have a scale to be able to do that. So I suggest कि आप वो scale use करें. I'll just draw using the line tool. ठीक है, अभी मैं इसका color जो है वो change कर देता हूँ थोड़ा सा. Yeah, let's put that as the color. So you can draw this as your line. ठीक है जी. You can draw a dotted line, of course. Sorry. ठीक है जी. So whenever the question wants you to draw, wants you to figure out the gradient using the graph, तो आप हमेशा जो है वो इस तरह से एक triangle बना लेंगे, and then you're gonna state the points. ठीक है. So the point that I'm using would be, अगर मैं इसको यहाँ पे ले आता हूँ, so this point right here would be 70.5. ठीक है. So the x coordinate would be 70.5 and the y coordinate would be exactly 1.2. ठीक है, because it's on the line 1.2. So ये इस line पर है. All right. And my next point is going to be where? My next point is going to be at 8.5 and 0.6. So this right here is going to be 8.5 and 0.6. These are my coordinates, and I can simply use the formula. What formula can I use? I can use m is equals to y2 minus y1 over x2 minus x1 to figure out what the gradient is. So that right there should turn out to be 1.2 minus 0.6. So that's 0.6 up top. And we have 70.5 minus 8.5. So that's going to be 62, if I'm not wrong. ठीक है. अच्छा, अब let's use a calculator to figure out its value. If I'm not wrong, it should be somewhere in the vicinity of 0.96 or 7. So 0.6 divided by, sorry, 0.6 divided by, we have 62. So 0.00967, 0.0097 कर देते हैं इसको. तो अब जाहिर सी बात है, because your examiners know that there of course is a range of acceptable values. ठीक है, तो यहाँ पर अगर हम रेंज देखेंगे तो मे बी it's 0.95 or 0.0095 plus or minus, or 0.01 plus or minus something. Again, I'll provide the marking scheme. तो आप marking scheme से जो है वो सुकून से देख लीजिएगा कि इसकी gradient जो है उसकी range जो है वो क्या है. बट जाहिर सी बात है, अगर हम gradient की range देखते हैं and your value does not actually fall into the range, so you'll essentially tweak your graph a little bit. Of course, in the exam you won't know that, but right now you can try and make sure that जो भी आपने गलती की है जिसकी वजह से आपका ग्राफ रेंज के, वैसे तो ग्राफ जो है वो रेंज के बाहर होना नहीं चाहिए. या वो गुड 10 to 20% मार्जिन मार्जिन ऑफ एरर. ठीक है, तो इतना जो है उससे भी ज़्यादा अगर आपका डिफरेंस आया है तो मीन्स you've done something wrong. So you need to make sure that when you draw a graph, you check the range from the marking scheme. And if, let's say, for example, your gradient or whatever value your question has asked you to figure out, if that falls out of the range, you need to correct it. मतलब आपने कोई मेजर चीज़ जो है वो गलत की है, तभी जो है ये रेंज से बाहर होता है. इतनी आसानी से ये रेंज के बाहर जाता नहीं है. ठीक है, so I hope that's clear. Extend your line until it crosses the y-axis. We did that. Measure the intercept C that your line makes with the y-axis. That should be a fairly simple job. This right here is going to be 0.52. ठीक है, 0.5 ये fifth division पर आएगा. एक division 0.02 units है. So we can say that this right here is going to be 0.052. We don't know what it is yet, so we don't necessarily need to put down the unit. अच्छा, ऊपर आंसर ऑप्शंस अगर आप देखें तो तकरीबन सारे 2SF के ऊपर हैं. तो I'm cool writing my answers in 2SF as well. Calculate the electromotive force of the cell using the equation where K is 1.0. So that should be fairly simple. हमें C की वैल्यू तो हम ऑलरेडी ऊपर निकाल चुके हैं. And the question says that K is equals to 1.0. So this right here is going to be 1.0 divided by 0.05 to... So we can figure that out. Let's use a calculator to figure it out. So we've got 1 divided by 0.052. And your answer is going to be 19.2. जिसको हम 19 लिख के 2SF के ऊपर we can move on. All right, so that should be fairly simple. 19.2 आना चाहिए. सारी चीज़ें 2SF के ऊपर हैं, so we can go ahead and say that this right here is going to be 19. I'm not exactly sure why the highlighter got selected, but okay, that's cool. Okay, so that's going to be 19. आगे यूनिट लिखा हुआ volts, तो I don't necessarily have to write down the units here. 19.0 लिखने की भी ज़रूरत नहीं है, वो 3SF पे चला जाएगा. ठीक है. Suggest one practical reason why, despite carrying out the experiment with care, the student's value for E may not be the true value. सो अगेन जाहिर सी बात है, बहुत सारे रीजंस हैं। वन ऑफ द रीजंस इज जो हम पहले डिस्कस कर चुके हैं, इंटरनल रेजिस्टेंस ऑफ द बैटरी, जिसकी वजह से बैटरी हीट अप होती है। कभी भी कोई भी बैटरी देखें वो हीट अप होती है। नाउ हीट इज यूजुअली व्हेन इलेक्ट्रिकल एनर्जी इज कन्वर्टेड टू heat energy. When does that happen? When your electricity comes across a certain amount of resistance. And if it's coming across a certain amount of resistance within the battery, means battery का भी अपना एक internal resistance होता है, ठीक है। तो उसके अलावा इससे पहले वो कूल डाउन वाला कि भाई वायर्स हीट अप हो जाते हैं, सब कुछ हीट अप हो जाते हैं। हीट अप हो जाने से आपकी वैल्यूज ही चेंज हो जाती हैं रेजिस्टेंस की। एंड अगर रेजिस्टेंस की वैल्यू चेंज हो जाती हैं तो दैट मीन्स योर रीडिंग्स हैव चेंज्ड, ठीक है। तो इस तरह से हम ये भी कह सकते हैं वन प्रैक्टिकल रीजन फॉर विच द ई वे नॉट बी द ट्रू वैल्यू इज बिकॉज ऑफ इंटरनल रेजिस्टेंस। सही है, हम ये लिख सकते हैं कि इट्स बिकॉज ऑफ इंटरनल रेजिस्टेंस ऑफ द बैटरी। अगेन इंटरनल रेजिस्टेंस के लिए आप लिख दें कि भाई हम बैटरी के इंटरनल रेजिस्टेंस की बात कर रहे हैं। That would be one. You can also write down continuous use of circuit heats it up, changes the values. Continuous use of circuit heats it up and changes resistances. ठीक है, तो इस तरह से हम इसको आंसर कर देते हैं। Forgive me for writing the answer in red, forgot to change the color. The results in figure table 1.1 show that the length L of resistance wire increases, the potential difference V decreases. So length increase करेंगे तो the potential difference V decreases. State how the result shows that L is not inversely proportional to V. तो इसके भी बहुत सारे तरीके हो जाएंगे आपके पास। अगर हम ग्राफ बनाएंगे, इट डज़ नॉट पास थ्रू द ओरिजिन। जो हमने ग्राफ बनाया है, इट डज़ नॉट पास थ्रू द ओरिजिन, ठीक है। वन अपॉन वी के सो व्हेन योर क्वांटिटीज, जिस तरह से हमने इससे पहले क्या करा है, बॉयल्स लॉ भी करा हुआ है, राइट। प्रेशर इज इनवर्सली प्रोपोर्शनल टू वी एज इन वॉल्यूम। नाउ प्रेशर इज इनवर्सली प्रोपोर्शनल टू वी अगर है तो वो वन अपॉन वी के साथ तो डायरेक्टली प्रोपोर्शनल होगा ना। इसी तरह से ओम्स लॉ में भी हमने किया है कि ओम्स लॉ नहीं, सॉरी, चलें खैर, बॉयल्स लॉ जो है उसी को यहाँ पे उसी को एज एन एग्जांपल सेट करते हैं। तो व्हेन द क्वेश्चन सेज स्टेट हाउ द रिजल्ट शो दैट एल इज नॉट इनवर्सली प्रोपोर्शनल टू बी, तो इट्स नॉट इनवर्सली प्रोपोर्शनल टू बी बिकॉज अगर इनवर्सली प्रोपोर्शनल होता तो वन अपॉन वी के साथ वो ओरिजिन के थ्रू पास करना चाहिए, ठीक है। सो लाइन डज नॉट, या graph, not line. Let's say the graph does not pass through the origin. Graph does not pass through the origin. ठीक है, so आपका ग्राफ जो है, it's not passing through the origin and hence these right here are not inversely proportional. So not inversely proportional में reciprocals का ग्राफ जो है वो directly proportional होता है. So that's something that you need to keep and that you need to remember. ठीक है, नेक्स्ट क्वेश्चन पर आते हैं। द नेक्स्ट क्वेश्चन says suggest a measuring device that the student uses to ensure that A, B and C, D are 120 meters apart, 120 centimeters apart. ठीक है, student measures the acceleration of a trolley rolling down a ramp, makes a ramp, draws a line, draws another line. थोड़ा सा अभी ओवरव्यू करते हैं, फिर बाकी सुकून सा आके जो है वो पढ़ेंगे। 120 सेंटीमीटर्स अपार्ट में जाहिर सी बात है मीटर रूल तो यूज़ नहीं कर सकते। मीटर रूल तो एक 100 सेंटीमीटर्स का होता है। तो द ओनली अदर ऑप्शन यू हैव इज द मेजरिंग सिलेंडर, नहीं द मेजरिंग सिलेंडर क्या बोल रहा हूँ, सॉरी माय बैड, मेजरिंग टेप, माय बैड। ठीक है जी, then you've got a ramp that makes an angle with the bench, so of course angle measure करना है तो you're going to use, हम लोग D बुलाते हैं इसको, आप डी लिखेंगे नहीं. The correct word for that is protractor. Take care, the student releases the trolley and at the same time starts a stopwatch. He stops the stopwatch, then the trolley has traveled 120. It replaces the trolley at the top of the ramp while with its front wheels touching. AB repeats the procedure twice. So front wheels touching. AB, ठीक है, suggest one reason why there is a large variation in these times. तो अब जाहिर सी बात है इंसान है, एक तो मेजर करने में ह्यूमन एरर आ जाता है. सेकेंडली, अगर आपने कभी बचपन में किसी टॉय कार्स के साथ खेला हो तो यू विल नोटिस दैट द टॉय कार विल ऑलवेज नॉट फॉलो अ स्ट्रेट लाइन. वो आगे पीछे थोड़ा सा डिविएट करती है. सो मेरे ख्याल में दैट राइट दैट वुड बी द बेस्ट. ह्यूमन एरर भी आप लिख सकते हैं, बट द बेस्ट वन वुड बी कि योर ट्रॉली डज नॉट ट्रैवल इन अ स्ट्रेट लाइन. तो इफ़ इट्स नॉट ट्रैवलिंग इन द स्ट्रेट लाइन तो जाहिर सी बात है व्हेन इट टेक्स अ डायगोनल लाइन इट्स गोइंग टू ट्रैवल मोर. So suggest one reason. So we can say that the trolley in this case does not always travel in a straight line. Okay, so the trolley does not always travel in a straight line. अब जाहिर सी बात है ह्यूमन एरर का है, आप वो भी लिख सकते हैं कि भाई ह्यूमन एरर होता है, रिएक्शन टाइम का डिफरेंस हो जाता है, सो ऑन एंड सो फोर्थ. सो या, Part 2. Figure 2.2 is a side view of the arrangement with the trolley at the start position of figure 2.1. Draw the position of the trolley when it has traveled 120 centimeters. तो जब जाहिर सी बात है 120 centimeters travel कर चुका होगा तो this position right here, this front wheel of the trolley is going to be right here. सही है, तो आप front wheel बनाएंगे और यहाँ पे ट्रॉली बना देंगे एक रफ सी. ठीक है, सो यू डोंट नेसेसरली हैव टू ड्रॉ वेरी एग्जैक्ट रेप्लिका ऑफ द इमेज दैट दे हैव. ठीक है, कैलकुलेट द एवरेज टाइम फॉर द ट्रॉली टू ट्रैवल अ डिस्टेंस ऑफ 120 सेंटीमीटर्स. तो हमें टाइम दिया हुआ है 0.7, 0.8 एंड 0.95. तो इसका हम एवरेज निकाल लेंगे. सो दैट्स गोइंग टू बी 1.51 एंड 1.51, तो ये 2.44 हो जाएगा. एंड 2.44, 2.4 is 0.8, फिर 133 इफ़ आई एम नॉट रॉन्ग. एक बार कैलकुलेटर से भी चेक कर लेते हैं. तो दिस राइट हियर इज गोइंग टू बी व्हाट, आई मे बी रॉन्ग. यस आई एम, ये 6 होना चाहिए, जिसकी वजह से दिस राइट हियर मैंने गलती से 0.244 ले लिया. इट्स 0.246, जिसकी वजह से इट्स गोइंग टू बी 0.82. Calculate the acceleration of the trolley down the ramp using the equation giving the unit of your answer. Now it's acceleration, so I'll directly write down the units meters per second squared. And now I need to figure out the acceleration, which is 2 times the distance. So 120 centimeters, of course, divided by the average time, which is 0.82 ka square. ठीक है, लेट मी जस्ट राइट दैट अगेन, बहुत कंजस्टेड हो गया था. सो 2 इंटू 120 सेंटीमीटर्स. अगर आप सेंटीमीटर्स में नहीं करना चाह रहे, अगर आप चाह रहे हैं कि भाई मैं इसको SI यूनिट्स में लूँ, तो आप 0.12 मीटर्स लेंगे. बट ओवर हियर इट्स बिकॉज द क्वेश्चन हैज़ गिवन यू द राइट टू चूज़ विच यूनिट्स यू वांट. आप यहाँ पे सेंटीमीटर्स जो है वो यूज़ कर सकते हैं. डिवाइडेड बाय 0.82 का स्क्वायर. नाउ यहाँ पे तो आपका आंसर जो है वो अप्रॉक्सीमेटली कितना होगा. स्क्वायर, लेकिन स्क्वायर क्यों नहीं आया सही से. ऑलराइट, so this right here is going to be 0.082 square. I'm going to use a calculator here to figure this out. So it's going to be 240 divided by 0.82 का square. ठीक है जी, so it's going to be 356.9. Let's see, my answers are in how many significant figures. So my answers are in 2 significant figures, so I'm going to use 2 significant as well. So my answer should be 356 है, so 356 should become 3 60 एंड इसको हम सेंटीमीटर्स पर सेकंड कर देते हैं. ठीक है, तो that right there would be the correct way of writing this down. Then you've got the question says suggest how the student could modify his experiment so that a more accurate value for the acceleration of the trolley is obtained. तो एक्सेलरेशन का आपने थियोरी के अंदर एक एग्जांपल पढ़ा था वेयर लेज़र गेट्स वर यूज्ड, सो टाइम गेट्स या लेज़र गेट्स वर यूज्ड. सही है, तो वो आप यूज़ कर सकते हैं, आप सेंसर्स यूज़ कर सकते हैं. यू कुड एक्चुअली have someone, the student can actually get someone to help them कि भाई वो जो है वो सिर्फ टाइम स्टार्ट या लेट्स से फॉर एग्जांपल एक बंदा जो है वो सिर्फ one of the kids is only going to let the trolley go, and the other kid is going to measure time, so on and so forth. So we can say let's use a black one, get help from another student. ठीक है जी, get help from another student. We can say use laser gates and sensors. मेरे ख्याल में laser gates जो है मैं गलत कह रहा हूँ. I'm thinking that light gates would be what is the proper word for it. So let's just say that we are using light gates and some sensors to measure the time, so on and so forth. ठीक है, तो इस तरह से आप इसका आंसर देंगे. Then we have question number 3. Question number 3 says what? Student measures the focal point f of a convex lens. She sets up the apparatus as shown in figure 3.1. Illuminated object is the shape of an equilateral triangle as shown in figure 3.2. Right? ठीक है, illuminated object, the object is drawn full size. She switches on the lamp and places the lens a distance of 20 centimeters. So this right here is 20 centimeters. From the illuminated object, she adjusts the position of the screen by moving it slowly backwards and forwards until a sharp image of the illuminated object is formed on the screen. The image of the illuminated object formed on the screen is shown full size in figure 3.3. Cool. State two differences between the object and the image. Obviously, आपका image magnified है, तो lenses कराते हुए मैंने आपको images की. So we discussed three properties of an image. सही है. So we discussed magnification, whether it was magnified or diminished. We discussed whether it was inverted. ठीक है. Inverted का मतलब ये है कि upside down. Or the third one was whether your image is going to be real or virtual. अब जाहिर सी बात है यहाँ पे real और virtual की तो बात नहीं चल रही, तो of course differences in the two objects and the image would be image is magnified. Of course, image is magnified, so relatively compared to the object, your image is much larger, magnified. Image is magnified, image is inverted. So these are your two. Image is inverted. ठीक है, अगर आपको ये properties याद नहीं है तो please याद कीजिए. These properties are very important to remember. May measure the height, age of the object. Now, of course, this is like 150% of the correct value. So I'm only going to assume values over here. I'm not exactly sure whether they are going to be right or wrong. But मैं assume करता हूँ कि this looks very similar to 1 centimeter. So I'm going to say कि भाई ये 1 centimeter होना चाहिए. And this looks very close to approximately maybe 2.5. So this is 1, this is 2, yeah, so 2.5-ish centimeters. ठीक है. So again, आप marking scheme से जो है वो confirm करेंगे कि what's the correct. So the height of the object I'm assuming is 1 centimeters. The height of the image I'm assuming is 2.5 centimeters. Again, we don't necessarily need to write the units here. वो यहाँ पे site पे लिखे हुए हैं, so we can skip that. ठीक है. Then we can say calculate the magnification m using the equation. So hi over h naught. So 2.5 divided by 1 is 2.5, right? Calculate the focal length of the lens using the equation. So 1 plus mu upon 1 plus m, where u is equals to 20, which the question gave you as the initial distance from the object, of the lens from the object. So we can easily do that. M magnification हमने 2.5 निकाल दी times 20 divided by 3.5 हो जाएगा, which is 1 plus 2.5. So this right here is going to become what? 50 divided by 3.5. So that should be somewhere in the vicinity of 14 point something. So 14.4 if I'm not wrong. जो इन calculations के हिसाब से जाएंगे हम तो 14.4 भी नहीं होगा, times 2 है ना, 14.28 या 14.3. अब जाहिर सी बात है, ये आपको एग्जैक्ट वैल्यू जो आप मेरी वैल्यूज़ यूज़ कर रहे हैं तो उससे तो आपको एग्जैक्टली 14.28 के करीब मिलेगा. सो 14.3. यू राइट इट. यहाँ पे यू 3 SF पे दिया हुआ है तो आप 3 SF पे आंसर दे दें, वरना आप 2 SF पे मेरे ख्याल में यहाँ पे ना दें तो बेहतर है. Correct questions giving you a value in 3 significant figures, so it's expecting you to use three significant figures as well. या बाकी जाहिर सी बात है आपके पास पेपर होगा तो आप पेपर के ऊपर जो है या तो भाई यू जस्ट ट्यून डाउन द जूम टू 100%. जूम जब 100% होगा तो आपके पास एग्जैक्ट वैल्यू होगी and you can use that to figure it out. Use a scale. I don't have a scale handy with me right now, तो आप scale जो है वो use करें. I'm pretty sure that I'm close to the value but it's not going to be the exact value. तो yeah, ये चीज़ फिगर आउट करके यू कैन गो विद द एग्जैक्ट वैल्यू. मार्किंग स्कीम से फिर उसको आप चेक कर लीजिएगा. राइट. Going on to the next question, I'm guessing this should be the last question. Uses uses a plotting compass to plot the pattern of the magnetic field around a straight wire. Right hand rule, concentric circles. I hope that these things ring a bell. The student sets up the circuit as shown in figure 4.1. आपको याद होना चाहिए कि the magnetic field of a current carrying wire is found using the right hand rule. And right hand rule में भी फिर आपको याद होना चाहिए कि जो pattern बनेगा that's going to be concentric circles. Alright, so I hope that everyone remembers that. Wire is arranged vertically and it passes through the middle of the horizontal rectangular cord. That's cool. Describe how the student uses the plotting compass to plot the pattern of the magnetic field when the switch in the circuit is closed. You may add figure 4.1 to help explain your. ठीक है. So in this case वो आपके नोट्स के अंदर पूरा जो है वो प्रोसेस लिखा हुआ है. हमने क्लास में भी डिस्कस किया था कि you put a compass at one point. So let's say for example if I put a compass over here. So let's start off with this. I put a compass over here. Now, ज़ाहिर सी बात है, battery, the positive is over here, the negative is over here, the current will be going downwards, and if the current is going downwards, then you should have a clockwise direction. So the magnetic field must be in a clockwise direction over here. ठीक है. So अगर आप एक compass रखते हैं तो the compass should be, इसको let's zoom in a little bit. So if we would put a compass over here, it would be pointed downwards. ठीक है. So what you are going to do is you are going to put a point over here. Then you are going to draw the compass again. It's going to point here. आप यहाँ पर एक point बनाएंगे. And then you are going to draw the compass again. Let me just adjust this right here. Compass आप वापस बनाएंगे. Oopsie daisy. Then it's going to point here. यहाँ पर एक point mark कर देंगे. आप compass वापस बनाएंगे. And you're gonna keep following or doing this for, so ये चलता रहेगा और वापस से आपको यहाँ पे लेकर आ जाएगा. So hence you're going to form a circle. फिर हम next compass को जो है वो यहाँ पे रखेंगे and then it's gonna make you fall into another circle, and that's why we get essentially concentric circles. ठीक है. So that's what I mean by concentric circles. So again, what are you going to write? So you're going to write, okay, first place a compass near the wire, and see the direction of the compass. So place, oopsie, now this is too thin. Now I'm gonna go with this. So place a compass near the wire. So we place a compass near the wire. Draw a dot where the compass points north, and place another compass in front of it. Okay, so we place another compass in front of it. And then we say, okay, mark where the next compass points north, and place another compass in front of. Okay, repeat till you reach the initial point. Say repeat till you reach the initial point. मतलब वो आपको घुमा के वापस उधर ही ले आएगा. And then we are going to have to add start at different points. So like I said, पहले आपने यहाँ से start लिया, अब आप यहाँ से start लेंगे to get multiple magnetic field lines. ठीक है. So इस तरह से you should be able to get the 3 marks. State what else the student can deduce about the magnetic field in this investigation. So जाहिर सी बात है, strength of the magnetic field by seeing how far the fields are. The direction, जाहिर सी बात है, जो आपको direction मिलेगा. So we can just write down strength of magnetic field. That should be plenty. ठीक है, हमने strength of the magnetic field लिख दिया है यहाँ पे. So yeah, any more questions? I doubt that. No more questions. Yep. ठीक है जी. So अब आपके पास और कोई सवाल नहीं है, तो I hope कि ये 2021 paper 4 का second variant है, and I hope that this clears the air for everyone. And अगर कोई questions हैं, so if you're watching this on YouTube, so you can post that in the comments. But if you're my student, you can always ask me in class. ठीक है? Take care, bachas. Tata bye bye. Allah Hafiz. Bars out.